Imagine a world where oceans are made of molten lava, where rocks vaporize into the air, and supersonic winds whip across a scorched surface. This isn't science fiction. It's K2-141b, a real exoplanet 202 light-years away, orbiting so close to its star that it's locked in a fiery embrace. Discovered in 2018, this super-Earth is 1.5 times our planet's size, yet it's a hellscape unlike anything we've ever known. With a day lasting just 6.7 hours and temperatures soaring to 3,000 degrees Celsius, K2-141b challenges everything we understand about planetary survival. How does a world like this even exist? What can it teach us about the cosmos? This documentary dives into the blazing mystery of K2-141b, a planet where extremes rule: lava oceans, rock rain, and a night side frozen at minus 200 degrees Celsius. We'll explore its discovery, unravel its alien nature, and ponder its place in the universe. Is it a glimpse of Earth's distant past, or a warning of what's possible out there? Join us as we journey to this molten marvel and ask, what secrets does K2-141b hold in its fiery heart? To understand K2-141b, we need to rewind to the early 21st century, when humanity's hunt for exoplanets, worlds beyond our solar system, kicked into high gear. The Kepler Space Telescope, launched by NASA in 2009, was a game-changer. Its mission? To stare at thousands of stars, watching for tiny dips in light as planets cross their faces. By 2014, Kepler's original mission had ended, but it was reborn as K2, or Second Light, scanning new patches of sky. It was during this phase, in 2018, that K2-141b emerged from the data spotted in the constellation Aquarius. The discovery wasn't just luck. It built on decades of astronomical progress. In the 1990s, the first exoplanets were found using the radial velocity method, tracking a star's wobble caused by an orbiting planet's gravity. But Kepler's transit method, detecting light dips, opened the floodgates, revealing thousands of worlds. K2-141b, officially epic 246,393,474.01, was confirmed with help from the HARPS-N spectrograph in Italy, which measured its mass. Astrophysicist Andrew Vanderberg, part of the K2 team, recalls, "We saw this tiny flicker in the light curve and knew we'd found something wild." K2-141b orbits a K-type orange dwarf star, cooler than our Sun but still fierce. Its ultra-short orbit, just 6.7 hours, places it a mere 0.007 Australian dollars from its star, 41 times closer than Mercury is to the Sun. This proximity hinted at extremes, but it was the planet's density, 8.2 g/cm superscript 3, 1.48 times Earth's, that stunned scientists. That figure, derived from transit and radial velocity data, suggests a massive iron core, making up 30 to 50% of its mass. K2-141b wasn't just another rocky world. It was a super-Earth on the edge of oblivion, a product of stellar evolution and cosmic chaos, waiting to reveal its secrets. Let's plunge into the molten core of K2-141b's story, exploring its nature through three key lenses: its formation and structure, its extreme environment, and the science behind its alien weather. Formation and structure. K2-141b likely began as a molten ball of rock and metal, born from a disk of gas and dust around its star billions of years ago. As a super-Earth, it's 1.51 times Earth's radius and 5.08 times its mass, placing it between Earth and Neptune in size. Unlike gas-rich mini-Neptunes, its high density, 8.2 g/cm superscript 3, points to a rocky composition with a hefty iron core. Scientists estimate this core occupies 30 to 50% of its mass, surrounded by a silicate mantle. Dr. Nicholas Cowan of McGill University explains, all rocky planets, even Earth, started molten. K2-141b is stuck in that phase. Its proximity to its star, 0.007 Australian dollars, suggests it migrated inward over time, a process called orbital decay, locking it into a 6.7-hour orbit. Tidally locked, one side perpetually faces the star, a cosmic dance frozen in extremes. Extreme environment. K2-141b's environment is a nightmare of heat and contrast. Its day side, bathed in stellar radiation, reaches 3,000 degrees Celsius, 5,432 degrees Fahrenheit, hot enough to melt and vaporize rock. The equilibrium temperature, averaging both sides, is 2,039 K, 1,766 degrees Celsius. But the day side's reality is far harsher. With a low albedo of 0.3, it absorbs most light, intensifying the heat. The night side, however, plunges to minus 200 degrees Celsius, minus 328 degrees Fahrenheit, a frigid wasteland. This stark divide is due to tidal locking, where one hemisphere roasts while the other freezes. The planet's surface isn't solid. It's a magma ocean, tens of kilometers deep, made of molten silicates and metals. Compare that to Earth's crust, just 5 to 70 kilometers thick and solid. K2-141b's orbit, shorter than any other planet with a precisely measured mass, amplifies these conditions, making it a laboratory of extremes. Alien weather and dynamics. Here's where K2-141b gets truly bizarre. Its atmosphere isn't air, it's vaporized rock. Temperatures on the day side turn silicates into gas, forming a thin, metallic haze. Winds exceeding 1.75 kilometers per second, 5 times the speed of sound on Earth, sweep this vapor to the night side, where it cools and rains back as solid rock into the magma ocean. This cycle mimics Earth's water cycle, but with molten minerals instead. A 2020 study in Monthly Notices of the Royal Astronomical Society modeled this process, predicting currents in the lava oceans flowing back to the day side to evaporate again. Dr. Laura Kraidberg, an exoplanet researcher, marvels it's a planet-sized volcano with weather unlike anything we've seen. If sodium dominates the atmosphere, it might even form slow-moving glaciers of solid metal. This dynamic system is K2-141b's defining trait, a world in constant upheaval, teetering on the edge of chaos, offering a glimpse into planetary evolution at its most raw. As of March 2025, K2-141b remains a fiery enigma, 202 light-years away in Aquarius. Since its 2018 discovery, scientists have leaned on data from Kepler, Harpsen, and the Spitzer Space Telescope to piece together its story. Spitzer's infrared observations in 2020 confirmed the day-night temperature split, 3,000 degrees Celsius versus minus 200 degrees Celsius, validating models of its magma oceans and rock vapor atmosphere. Today, the James Webb Space Telescope, JWST, launched in 2021, is poised to take the next step, peering at K2-141b's atmosphere in unprecedented detail. The challenge? It's too faint and distant for direct imaging, so we rely on transits when it passes in front of its star, dimming the light by a fraction. JWST sensitivity could reveal the chemical makeup of its vaporized rock atmosphere, perhaps sodium, silicon, or oxygen compounds. Dr. Cowan notes, Webb could confirm our predictions, showing how this lava world ticks. But mysteries persist. How thick is the atmosphere? Does it erode into space over time? Current trends in exoplanet science favor studying such extremes to understand rocky planet evolution. K2-141b's data, paired with simulations, positions it as a key case study, even as its hellish nature defies easy observation. What's next for K2-141b? Its future unfolds over millions of years, with 3 possible paths ahead. Scenario 1. Atmospheric erosion. K2-141b's intense stellar radiation could strip its rock vapor atmosphere away. Over eons, solar winds might erode it entirely, leaving a barren, airless rock. Dr. Kraber predicts if the mass loss is high, it could become a charred husk, a fate many close-in planets share. This would dim its reflective nebula, altering its transit signal by 2050 or beyond. Scenario 2. Stable lava world. Alternatively, K2-141b might endure as a lava planet. If its magma oceans replenish the atmosphere faster than it's lost, it could remain a molten marvel for billions of years. The 2020 study suggests this balance is possible with volcanic activity driven by tidal heating. Dr. Cowan muses, it might outlast its star, a testament to resilience. Future JWST data could test this by measuring atmospheric stability. Scenario 3. Planetary transformation. A wildcard. K2-141b could migrate outward if its star's dynamics shift, cooling its surface. Less likely, this would solidify the lava into a rocky crust, mimicking Earth's early cooling. It's a long shot, but exoplanet science thrives on surprises. Whatever happens, K2-141b's fate will refine our models of super-Earths and lava worlds, illuminating the life cycle of planets born too close to their stars. K2-141b is a world of extremes, a super-Earth where lava flows, rocks rain, and heat reigns supreme. From its 2018 discovery by Kepler to its current scrutiny under JWST, it's revealed a universe stranger than we imagined. At 1.51 times Earth size and 5.08 times its mass, it's a molten mirror of our planet's fiery youth. Its 6.7-hour orbit, 3,000 degrees Celsius day side, and minus 200 degrees Celsius night side paint a picture of cosmic chaos. It's a key to understanding planetary evolution. This lava planet's story isn't over. Will it erode, endure, or transform? Each possibility ties us closer to the cosmos. As Dr. Vandenberg says, K2-141b shows us nature's wild creativity. So, look up. What other worlds await? K2-141b challenges us to explore, to question, and to marvel at the fiery wonders beyond our pale blue.